Hello and welcome to Quick Start to Coding with Swift. Please may I introduce my co-host, Matt. Matt Hanlon is a long-time software developer, coach, teacher and dad in Ireland.
Thanks, Steve. And may I introduce Steve Bunce, an author, teacher, associate lecturer, and dad in the northeast of England.
Thanks, Matt. We have an exciting session for you today. Today, we are going to put our commands together to form new behaviours called functions. We're going to use the functions to help Byte solve a problem. He can't turn right. So how can we use move forward and turn left to help Byte turn right? Let's get started. Hello and welcome to Unplugged with Steve. Today we have two parts to our session. The first part, we're going to try and help our friend Byte with a problem. And in the second part, you're going to work together with a friend to try and solve a problem too. You're going to do that by playing a game. So our first part, helping Byte. You've already used commands for Byte such as move forwards and turn left. Let's see, there's my left with the L. So move forward and turn left. So you've helped Byte out with those commands. But today Byte has a new problem. Byte wants to turn to the right. Okay, so how are we going to do that? I'm going to ask Jimu here to come and help me. Jimu? Jimu's our friendly robot. Here we can go. We can imagine that Jimu is Byte. So Jimu can turn left easily. And by turn left, we actually mean turn left 90 degrees. Okay? So Jimu can turn left, no problem. But what happens if Jimu wants to turn to the right? But we only have the command to turn left. Well, this is our problem, isn't it? Jimu would like to go that way, but can only turn left. So that is our problem we need to solve. So I'm going to pause there and let you have a think. Try and think, how could you get Jimu or Byte to go that way when they can only turn left? What would be your commands for Byte? Okay, did you manage to come up with an idea? We wanted Jimu or Byte to be able to turn to the right, but the commands they had were move forwards and turn left. So, have you got an idea now? Good, because that will be really important in a moment when you do your coding with Matt. Okay, that is our first part of the session. But I think before we move on to our second part, I think I need to go and practice this. So, I'll put my dancing shirt on. There we go. And I shall go and see if I can practice turning right by only using the command turning left. Okay, see you in a moment. Okay, so how did you get on? Did you manage to turn left? Did you manage to turn right? Brilliant. So I'm pleased you've managed to find a problem to solve. So let's go into our second part of the session. Right, Jimmo, if I could ask you to sit just over here. Thank you. You can help me because I'm going to play a game against you. Okay, so we are going to think about playing a game called dots. Okay, so you might call this dots, or you might call it boxes, or you might call it squares. Let's have a look. To do this, you're going to need some paper and a pencil, or you could use maybe a pen as well. So let's try this out. So we're going to play the game called boxes or squares, and the idea is you put on some dots. So you probably recognise this when I start talking. If I put in 1, 2, 3, 4, 5 dots, and then I do 1, 2, 3, 4, 5 rows, and then fill in those dots. Okay. They don't have to be too straight, don't worry. There we go. There's my dots. Have you played this game before? Do you recognise this? So I will take one turn and I shall draw a line like that. And then it would be Jimmo's turn. And Jimmo could put a line on like that. Then it could be my turn, and let's see, I'll put a line here. And then Jimmo's turn. And then my turn. And Jimmo puts a line on. And oh look, I can make a square or a box. So if I draw my line there, there is my square. And I can put my initial in there. There's an S for Steve. Okay, now if Jimmo got a line, so for example, if he then saw it as his turn and he could do a line, then he could put a J for Jimmo in there. Okay, so can you see how you play? So you take turns to draw lines, and it's the one who can get the most boxes, they win the game. Okay, so over to you. Go and give it a try and see who wins and who makes the most boxes. See you in a moment. Okay, now I'm going to add one little change to our game. When we were playing the game before, you could just put a line anywhere you liked. So for example, you could put a line here and a line here like this. But now I'm going to add this rule that you can only put a line in if it's touching another one by going left. So let me see. Here's a line. If I want to put in another line, I've got to make this line go 1. I've got to make it turn left. And this line, look there, along there, make it turn left. Alright, let's see, this line, turn left. And this time, turn left. Oh, if I wanted to make that box look, I'd have to go this line, turn left. 1 for me. So what I like to do is try and play the game like that and see if you can still play it. Does it break the game? Or actually, can you still just play as you did before? Who's going to be the winner? Away you go. Okay, how did you get on? Could you still play the game? Let's see how we got on. Let's see who the winner is. So here we are. Let's count up the squares. Jimu has got 1, 2, 3, 4, 5, 6, 7, 8 to Jimu. And I've got 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's a draw. Well played, Jimu. Okay, so you can play this game. You can play it later today as well if you want to play it with your friends. And you can follow the rules, which are to make the boxes. But maybe you could add to that game. Maybe change the rules a little bit and see what happens. Okay, thanks for playing. See you again.
Okay, thanks, Steve. Yeah, today we're going to be talking more about functions. We learned about commands yesterday, where we figured out what instructions we could send to Byte to get Byte to walk around the maze and solve puzzles for us. Today we're going to learn all about creating our own commands, which is functions. So let's go take a look at Swift Playgrounds. We're going to open that up today. We're staying with Learn to Code 1. So we're going to go over to our Learn to Code 1 playground, open it up. Now, if you're following on from yesterday, where we learned about commands, we'll be in this add a new command section. And if not, we're going to go tap on this name here, and we'll get up our list of all the different lessons inside Learn to Code 1. And we're going to tap on the introduction to functions. So functions are all about grouping tasks. And we were doing groups of tasks yesterday when we had Byte perform a certain number of commands. And so every day, to tie it back to real life, we perform a bunch of different tasks without even thinking about all the different components of those tasks. For example, tying our shoe. If I tell you to tie your shoe, you can go, oh, that's cool. I'll go off and do that. I know what to do. I know how to organize the strings so that they do the right thing. And that I wound up with a shoe that's going to stay on my foot. These might be the steps you use to tie your own shoe. So loop, swoop, and pull. Those would be the distinct steps that we follow to get our shoe tied. Now, a function would be something like me saying to you, tie your shoe. It's a name that I've given to that set of actions that I want you to perform. So this is how we might write it in code. We use this func keyword. We have a name for our function here, tie my shoe. We have our fancy camel case lettering. So we have no spaces in our function name. It says tie, capital M for my, and capital S for the word shoe, followed by these two parentheses that tell Swift this is a function that we're going to be able to call. And then inside of our braces, we have all of the commands that we want to perform when we get asked to use that function. So we're going to loop, swoop, and pull. So in this case, if we were to turn those into functions of their own, they might look something like this. So we're calling them as functions because they've got their parentheses at the end of each command. And there we go. After we define it, we can call it by name. We can just call tie my shoe, followed by the two parentheses, and we'll actually run those three commands. Let's try it out. Let's try it out with some actual code. Okay, so now we're going to be start talking about composing a new behavior. Yesterday, if you were following on from the commands lesson, we were able to turn left, move forward, collect a gem, and toggle a switch. Those were the commands that were given to us, so someone else wrote those commands for us. So now what we want to do today is we're going to have to solve puzzles that are a little more complex. So in this one, I know Byte's going to move forward, but if I only have the turn left command, how am I going to turn and get that gem? I'm going to give you a couple seconds to think that one over. And in addition to coding time, this is more like thinking time, because sometimes we have to sit back and think about the problem we want to solve before we actually go and solve it. Now, can you think about what you're going to do? The first part might be a little bit easier. You could say, okay, cool, I need to move forward. I'm familiar with that command already. But when I get to this little turn here, how am I going to get Byte to go face the right way to get to my gem? Have you figured it out yet? I'm going to tap in here to enter code. We'll see our familiar commands down in the autocomplete bar. You can see that I have the 4 that we just talked about. How's your solution coming along? Can you solve it before the time's up? All right, let's take a look. So we need to move forward a few times. So I'm going to tap on move forward. Move forward again. That puts me about here. Move forward one more time. So I've moved forward 3 times. Now, if I want to turn left to turn right, how many times would I have to do that? So turn left will put me facing this way. If I turn left again, this is what I love about being able to drag this playground around. I'm facing back the way I came. And then if I turn left again, then I'm facing towards the gem. So let's move forward once, twice, 3 times again. And we'll collect the gem. Let's try that out. So hit run my code. Off byte goes, moving forward. Turning left, turning left, turning left. Now we're facing the right way. Oh dear. All right. We completed our puzzle. By combining those 3, it tells us that we've composed those. So composition is where we combine existing code to complete a new task. So we didn't have a turn right command, but we used some other tools that we had. And that's what we've been doing over these last couple of days and these whole 10 days is we're giving you tools for programming because you always will use these tools, sometimes in different combinations. Sometimes you get new tools that replace the old ones, but you always have that early foundation of tools. So let's go on to the next page. Now we're going to create our own new function. The really nice thing about functions is once you've figured out a way to compose commands to do something new, you can create a function and then you have that for the rest of your time. You can call that, and it's much easier to call turn right than to call turn left 3 times. So what we're going to do, the goal for this page is define and use our own function to turn right. So we can look at this puzzle. We have to get byte over to this switch to toggle it. This switch is fine, it's turned on already, but we need to get byte over there to toggle that switch. So I would probably, to solve this puzzle, if I think about it, go this way, turn right again, down the steps, turn right, all the way over here to toggle that switch. What way would you solve it? We might be able to use this portal to portal over there and then go solve it. But I know that I definitely want to turn right. I'm going to go with this solution. So what do you think you would put inside this turn right function? If we want to be able to call that, just like we showed in the example of calling tie my shoes. Can you think? Here, we'll give you 1 minute to try to figure out what would you put in that turn right function. And then how are you going to use it? Once you've figured that out, or even if you haven't, how are you going to get to that switch to toggle it? And as with any of these, I'd love to see your answers. Even though we're not live anymore, I would love to see your answers in the comments. Come up with some of your own solutions. Because there's always more than one way to solve a particular problem. This is the next big step in programming because now we're starting to really architect our solutions, which just means that we're thinking about how we're going to build this and then how we're going to use these tools afterwards. So, okay, so we talked earlier about turning left 3 times to turn right. So let's hit turn left, turn left, turn left. Wait a minute, you know what? I just saw in here in the autocomplete bar, I actually have a turn right function that I can call. Well, why don't I use that instead? Let's delete those and just call turn right. And now I'm going to start to solve my puzzle. So I'll do move forward, and now I'll use my turn right function. I'll be facing that way. I'm going to move forward again, turn right again. I'll move forward once, twice, and then I'm going to have to turn right again. So I'm facing this way. I'll do 1, 2, 3, 4. So 4 move forwards. Then we're going to turn right again, move forward, and then at this point we should be on the toggle switch. So we'll toggle the switch. Let's try running this. We'll hit run my code. Byte moves forward. Ooh, and we have a problem. This is weird. Normally we get those red dots much earlier. So now we're getting a red dot while we try to run our program. And it's telling us to check our code for mistakes. Well, that's not super helpful. But what's happening is if we let's try stepping through our code to see what happens. Let's step through my code. So we move forward, I'm going to turn right, turn right. Ooh, you can see that that caret is actually bouncing between these two, this function and then this. Because what we're doing is we've created a thing called an infinite loop. This will never stop, and this is why we get an error at a certain point. Because when we call turn right, Swift says, you just told me about a function called turn right. I'm going to go call that function again, and we should be good to go. Well, then it tries to call itself again, and it says, I got to turn right. So it tries to turn right again. And that gets into what's known as an infinite loop. So it's one of the things we have to be careful with as coders. So let's delete that turn right. Let's try doing our 3 turn lefts. And let's step through our code to see how this runs. So now we're moving forward. We're turning right. So Swift jumps up to the function that we've just defined, and it's going to run the commands in there. And then once it's done running those commands, it jumps back down here and runs the next command until it hits turn right again, and then jumps back up to our function definition. This is hugely powerful, and it's a lot more complex because now when we write our code, it's not all just top to bottom. Now we're jumping around a little bit off to where we've defined the function. We have another set of commands. So it gets a little bit more complex to keep this all in our head. So perfect, we just wrote our first function. Let's move on to the next page. And in fact, we're going to skip collect, toggle, and repeat. Now, if you're flying ahead, this would be a great page for you to work on. But what we're going to do is we're actually going to look at nesting patterns and try to solve this puzzle. So this will show us how we can call functions from within other functions. And in fact, we've been doing that. So inside the turn right function, we're actually calling turn left function. The only difference is someone else defined the turn left function. So in this case, if we look at this page, we have turn around is already defined for me here. I've got turn left, turn left. I've got solve stair being called. Let's reset this page just to make sure that it's clean. So let's hit reset page. Yes, I'll reset the page. Okay, that's what we're starting with. So someone has defined the turnaround function by using 2 turn lefts, and that sounds fair, like it would work. We have another function called solve stair. So if we look at where byte is trapped, that's the stair. So to solve the stair, really what we have to do is move forward, collect the gem, turn around, and then move forward again. So we have our turnaround function defined, so we would probably use it in there. So let's try to break this problem down. Can you break it down? Here, we'll give you a minute to think about how you're going to break this problem down. We've got byte standing inside a little box of gems, and we have to solve each one of those stairs. There's 4 of them. And there are a few different ways we could solve this puzzle. And by breaking down our different chunks of the puzzle into functions, this actually will help us to solve the problem easier. Because what we could do is write enough in the function, maybe solve stair, so that we just solve one. We say, okay, great, now that we've solved one, let's try to figure out how we use that function and write some code around it to get us in the right position to use it again and again. How's your problem solving coming? All right, let's take a look. So we've got turnaround defined. We just kind of talked through it. Let's try getting byte to move forward once. That will put byte at the top of the stairs. We'll collect the gem, and then we'll turn around. So if we look down here, we have our functions that we've defined. In fact, we have our new turn right function defined as well. So use turn around, and then we'll move forward again. That's what's going to happen every time I call that solve stair function. Now, I could write all the code to have byte turn right and left and solve the whole puzzle here inside solve stair, but I'm just trying to focus on just that one piece. So let's try running our code and see what happens. So we call solve stair, we move forward, we collect the gem, we turn around, we move forward again. Okay, great. So now we're facing the next stair. Well, let's go down here. Now you'll notice that, and we'll actually run this otherwise. So right now I'm having trouble touching around the solve stair because it's such a small area. So what I'm actually going to do is I'm actually going to tap on solve stair again, and then it goes down to the next line for me. I'm actually going to call solve stair twice, and I'm going to run it by stepping through my code so I can see what's happening. So the code skips over, when we're executing this, we skip over turnaround function definition and solve stair, and we actually start running our code here. Because these function definitions just tell Swift, remember this for later. I might call this, I might not, but remember this for later because I'm going to use this function to solve my puzzle. Okay, so far we have something that will solve 2 of the stairs. We have 2 more to go. So what steps are you going to take? We'll give you 1 minute to figure out, if you're at this stage, how are you going to finish solving these stairs? I'm using my solve stair function twice. What steps would I take next to finish off the whole puzzle? The really nice thing is that I solved 2 stairs and I only had to write the code once because the solution to each stair was similar enough. Now that we're at this stage, how are you going to solve those last 2 stairs? Have you got it? Do you have the same solution that I have, or did you tackle it in a different way? I tackled it in this way, where I kept my different behaviors that I wanted to perform in a very specific set of functions. So let's take a look. What I might do is I'm going to use our new-ish function here, turn right, so that byte will turn right at this stage and be facing that way. And then I'm going to do the same thing. I'm going to call solve stair, solve stair. And let's step through our code and see what happens. So there goes byte up the stairs. We're in the solve stair function. We're collecting the gem. Inside turnaround, we jump up to the definition of the other turnaround function. We turn left twice, and then we go back to solve stair and finish the rest of the code inside those braces. And you can see how that jumps around a lot more. It's a lot more complex for you to remember all of this in your head. This is where Swift is excellent, because once we've written it down, Swift will remember all of this stuff for us. And we can call any one of these functions, and it won't have trouble remembering. Whereas it might slip our mind. All right, so we're on that last solve stair. We're going to turn around, turn left twice, back to solve stair. Perfect. We just solved a fairly complex puzzle in a really efficient way. We were really smart about how we organized our code in this one. Functions are a hugely important tool. We're going to use them for the rest of the time we're coding. In fact, we used them in day one when we learned about commands without us even knowing about them. But it's really powerful when you can start writing your own functions that you can use later or that someone else who's writing code can use later. It's a really, really powerful tool.